Yes, class, in the last class time period we couldn't calculate, no, so I had stopped at this point that orbital velocity was under root gm by r. By r, please have an idea that this means r plus h if height is present. If height is negligible, then this is the only radius which is present, which is equal to 8.9 kilometer per second. Remember, this is not per hour, per second. This will make a difference. This is a very high speed. Now, time period, in the homework questions also, there were questions based on time period. So let us calculate the time periods formula first. See, velocity is what? Velocity is displacement upon time, distance upon time. That's how we write the formula. Now, which velocity will you be putting? You will be putting up this velocity. Orbital velocity you have. Time period, we don't know. So we'll call this time period as 2 pi r divided by v, which we'll write it as equal to 2 pi r under root gm by under root r. This is how we'll write it. So see, if we square both the sides, or before squaring it, this will become, to rationalize it, we multiplied by root r. So this will become 4 pi. This becomes 4 pi square. This will become r square into r. That will make it r cube by gm. This is whole t square with an under root. So I'm not writing it as t square. Instead of that, I'm putting this under root sign. Now, value of r. As I've told you, r is not fixed. We have a certain separation. So that becomes 4 pi square radius plus height whole cube divided by g. This much under root. So what is t square ultimately equal to? T square is equal to 4 pi square r plus h whole cube divided by g m. This is how we'll write. Now, what is r plus h equal to? See, this is the formula of time period. You have that formula of time period. This is the formula of time period. This is the answer. But we will not stop here. We have to find out height also. So for that, I'm writing this r plus h whole cube. This is equal to g m t square divided by what was left? 4 and pi square were left. So r plus h will be equal to g m t square by 4 pi square to the power 1 by 3, because this is cube root over here. So finally height is cg m t square by 4 pi square to the power half to the power 1 by 3 minus radius. So this is the formula of height. Alright, this is the formula of height. Both of these you have to remember. This is height, whereas this is time period. Potential energy and kinetic energy also let us discuss, but first write it down, then we discuss. Write it from. Yes, yes, this time period is only applicable for orbiting because the velocity that we have put is orbital velocity. If there is a different velocity, you'll have to start it again from and put that value of velocity. Now, see regarding potential energy. So what is meant by potential energy? We have the formula of potential energy as minus G M small m by R. Yes. So this, in this case, this will be equal to R plus H. That's the difference what you will be using. Similarly, when we are talking about kinetic energy is equal to half mv square. Now you know which type of velocity to put. This is just for this, all these parameters. No, I'm telling you for orbital one, when the object is orbiting around. So the velocity that you will be substituting in here, we know the velocity. See, velocity is gm by r. So v square will become gm by r only, under root will be gone. So for kinetic energy, you will have what this will become, half. This becomes m, v square, this becomes gm by r. So this becomes gm m by 2r. This is the kinetic energy. So what is the total energy? Again, you know, you have to put in R plus H whenever this is needed. Now, when we are talking about the mechanical energy means kinetic plus potential. So Gmm by 2R minus Gmm by R. This is equal to minus Gmm by 2. This is the total energy. All these three are very important. Class total energy is formula, kinetic energy is this formula, and potential energy is this formula. All these are very, very, very important. And see, one more thing, let me tell you, when we are talking about this time periods formula, no, one more important term comes from this, that is geostationary satellite. See, in case of geostationary satellite, they are orbiting around the Earth at such a speed that from Earth, when you look at the satellite, it will appear that as if it is not moving. Sometimes it happens to when you look at the sky, you are seeing some object, or let's give the example of moon. Sometimes if you sit in a car and the car is moving and you look at the moon, what you will feel that moon is also moving along. So that's not the case. This means the satellite which is revolving. No, actually this is not happening. How can it be moving with the same speed as that of yours? There's a huge gap in between. There's such a long distance in between, and the velocities can never match, can never. But it appears. So that is why we say geostationary. Stationary means they're actually not static. I told you when we were discussing rest and motion that it is always with respect to frame of reference. So if the satellite is appearing to be at rest, that will be with respect to Earth. With respect to any other planet, it will be in motion. So satellite that revolves, let's come to the definition of geostationary satellite, a satellite which revolves around the Earth in an equatorial plane with the same angular speed and in the same direction as that of rotation. That's why it appears to be static. And it is always at rest with respect to Earth. This is important. Now, when we put in the value, this comes out to be 3600 kilometers. Time period, we know 24 hours. Gravitational constants value, you know, 6.671. And this one, mass of Earth, you know, 6.41. And this 4 is already a constant. Pi is 3.14. Radius of Earth is also there. Time we input it as 24 hours for Earth. So that height comes out to be 3600 kilometer. Class, you have to remember this value. Fine, 3600 kilometer, you will require it. So there are lots of uses. I'll just suggest you one thing, that please read these uses from NCERT also. Radio, TV channels, weather forecasting, all these geostationary satellites are helpful. I'll suggest you to read this also, because this is asked and this is important, and this information is not enough. Usually the class notes are enough, but wherever this is insufficient, I mention in the class itself. Write down this, then we'll see Kepler's law.
Defines the height of what?
This is the height, this is the separation from the Earth, from the surface of Earth to which this satellite is being placed. Suppose this is the Earth, here is the satellite. So this separation is 36,000 kilometers. Fine, Harsha?
Okay.
No, no, Harsha, not every satellite, only the geostationary satellites. Every satellite you're not able to observe also, no? This is just for geostationary satellite, this height, not for every satellite. Every satellite has its different own height. Let's start with Kepler's law.
Ma'am, can you scroll up once?
Okay.
Done, ma'am.
See, though, so the first law of Kepler is as follows. First law basically says that there are three laws which you have to study. First law basically says that planets revolve the sun in an elliptical orbit. Continuously, we have been using 2 pi r, 2 pi r as if it was a proper circle. So that time I told you that it's not a proper circle, and all of you are already aware of this fact that it's not a proper circle with radius r. If it is an elliptical orbit, then this separation will be something else, this separation will be something else, right? In a circle, no, you have a proper separation. If you choose any point, from the point you go to the center, you will get the same value of radius. But if it is an elliptical, somewhere it will be very small, somewhere it will be large. So you have to focus. Two foci are present. One focus is here, one focus is here. Focus is like the center of a circle. In a circle, since a circle is a symmetrical figure, at the center of a circle, you have the center. So the focus of the circle will be center. When we are talking about ellipse, elliptical shape, then you cannot have one point from where everything will be equal. So that's why we have 2 points of references or the foci. So one focus is here, one focus is here. Now we'll just focus on one of the foci. Suppose here your object is, here your satellite is. So this point is referred to from the separation. Let's take from the foci, we have taken this to be as R1. This is a shorter one, and the shorter one's periphery edge, this point is called as perihelion. On the other hand, from this focus towards the periphery of the ellipse, we have the aphelion. So you have perihelion and aphelion, and both are the separation. Now, what about the axis? The way we have diameters. Here, you cannot double the radius and you will get the diameter. If you double this, it will be somewhere here. If you double this will be more than this. So instead, what we do, we choose two axes, minor axis and major axis. So the longer axis, we call it as the major axis. This is the first diameter. And this we call as the minor axis. And if you take the half of it, that becomes semi-major axis, because you don't have the concept of radius now. Radius is completely different and diameter is completely different. Then again, minor axis, so this will be semi-minor axis. So this is the detail what you have to remember regarding the first law. Write down the first law, then I'll discuss the second law with you. Now see what is meant by the second law. For the second law, you have to understand the term aerial velocity. What is meant by velocity? Velocity means displacement covered per unit time, right? That is what is the definition of velocity. When we say aerial velocity, it means area that is changing. Instead of using the direct term displacement, if suppose I give you this P1 point and P2 point, you will join these points and you will say that is the displacement, right? That is what you'll say, that is the displacement that is occurring. So that divided by time is just velocity. But when I say area, the displacement of the area that is swept or area that is covered per unit time, that becomes aerial velocity. So concept of velocity, you already know, it's just an expansion of concept of velocity. That is what is meant by aerial velocity. Now see, from one point to another point, some area has been swept by the planet. This is the sun. And one area is the larger area because there are two axes, there are two types of radii which are available because of the presence of two types of foci. So areas will also be different. One area will be lesser, which will be near the one focus, and second will be greater. We are just talking about one of the foci. You already know that second foci is there. So when planet will come here, that will have a different reference. This will become the smaller one, this will become the major one. But theory remains the same for both of the cases. So let's say area A1 is this change in area. T1 is the time, V1 is velocity. Area A2, V2 is velocity, T2 is time. So all these are initial and final point. This will be P4. This will be P4. So velocity covered here is equal to velocity covered here. That is aerial velocity will remain constant. So A1 by T1 is equal to A2 by T2 is remaining constant. You can get questions also from here, but questions are very easy, very basic questions you have from this, but this can be asked. And yes, of course, see, why are we saying this constant? So the way we conserve momentum is conserved here also. That is external torque is zero. Because we cannot say external force is zero because this is also a rotation motion, and we have studied in rotational motion that torque comes into action. So angular momentum is conserved. Remember this. This is important. There are questions also based upon this line. That angular momentum is conserved. Write down the second one, then third one we'll discuss, and from third one we'll do a numerical also. Now the last law of Kepler, that is the law of time period. So time period, basically, you just have to remember, we are taking one of the axis, semi-major axis. Though you know because of the second law in detail about all the radii, you know all the details about all the axes, right? Now, here we will be considering only one axis, which is the semi-major axis, because this is assumed to be an average, more close to the average value of all the axes available. So we consider a what Kepler has mainly given, that the semi-major axis is taken. So it's like the radius of the circular orbit. We have a radius no, for a circle. So that radius is taken as semi-major axis. But behind this, you should remember the second law as well, that this is not just the radius of a circle. First law tells about you the elliptical shape, and second law tells you about all the different axes and radii and foci also. So but here for our calculation purpose, we require one radius at your level at least. So the time period which you are already aware of, time period that it takes for revolution to occur, this is directly proportional to the square of time period is directly proportional to cube of radius. It's a very important law which you people should remember, because questions are asked from this. So t square is equal to KAQ. So mainly ratio questions are asked. I'll show you. First, write this down.
Ma'am, so we're assuming it to be circular.
See, you have to assume it to be a circle. See, one radii only you can take for your calculation. Otherwise, see, the real concept no, which is present in reality. This is not such a small formula like this. For every portion, you have a separate formula. But at your level for class 11th in your syllabus, you just have this law of time period. In reality, we calculate so many points, we take so many points from here, opposite points, we calculate it from semi-major axis and semi-minor axis, and every axis has a different possibility for every other planet. So at your level, you cannot go into the details of it because that will be a different subject of astrophysics. So here you should just remember that assuming not to be a perfect circle. See, a circle you cannot assume because you already have the first law. It will then deny the first law. This is taken as the radius of the ellipse, you can say. But you should remember that this is analogous to the radius of circular orbit. This you can say. Analogous to the radius of circular orbit, semi-major axis you will consider. In reality, this is not just the axis which is present. Other axes and different time periods are also calculated from every point. Okay, Arsha?
Okay, ma'am.
Okay, so this question says that time period of planet X is around the sun is 100 years. Around the sun is 100 years. You have to calculate the semi-major axis and calculate radii of planet around the sun. See how will you solve this question. Time period around Earth. This square is directly a proportionality. Let me remove. Is equal to K. A is what? The radius of Earth. This whole square. Now, are you aware of this knot? What is AR? This is mainly TE square is equal to K. R square, even I can write for more clarity. Time period of Earth to revolve around the sun. This is 1 year. Now, why are we taking Earth? Planet is X. We will take this because this is one only which we know what is the time period and what is the radius. So with the help of this data, we can find some other information. And again, radius of Earth is also known. So that's why this will be our reference. And by taking the ratio, we can find out the value of the radii.
Ma'am, how did we get a square?
A square is in the law, no? Okay, acha, cube this you're saying. Okay. Yes, this is cube. This is cube. R cube. So radius of Earth, this. See, when you're taking, this is not the radius of Earth, you will take radius. One radius of Earth is this. This from the center of Earth to the surface, this radius. No, this you are not taking. Because you are not calculating rotation on or any other component of Earth. When we were talking about this was the ellipse, here was the planet. If here is our Earth, this we have to take, right? So here this is 1 astronomical units. Do you know what is, how much is this? 1.09 into 10 to the power 11. This is, please remember this because this is given in your first lesson, physical world in NCERT. 1.09 into 10 to the power 11 meters. Now, coming to the second one, for that planet X, this is equal to K. This is A cube. This A is missing. This A is unknown, which we have to find out. And what is the time period here? This is given as 100 years. So since this is given in years, we don't need to convert this into 3600 seconds into 60 and all. We have this already in years. Years, SI unit will be cancelled. So when you take up the ratios, TE square will be equal to KR cube by TX square, KA cube. KK will be cancelled. This becomes 1 by 100 whole square. This is 1.09 into 10 to the power 11 whole cube divided by A cube. From here, you can calculate the axis. So when it is saying calculate semi-major axis, you have actually calculated the radii of the planet around the sun. All right, so instead of semi-major axis, it can be asked to you as radii of planet. This is actually not a separate question. This is a part of the same question. Semi-major axis here is the radii of planet. You know, mention it in brackets. This is for reference. Write it down. Any doubts if you have from gravitation lesson, let me know. And yes, Harsha, this is there in your syllabus.
Okay.
Fine class. So we'll start with mechanical of properties of solids straight away in the next class now. Elastic bodies and stress strain. These will be the initial topics which we'll cover in the next class. Fine. You people can leave. Thank you so much. Let's meet on Tuesday.
Ma'am, I have a doubt in a question.
Say Harsha.
Ma'am, in the question, using concept of escape velocity, calculate the radius of black hole we did earlier.
Yes, which we did in the last class.
Yes, ma'am. I didn't understand how we got R should be less than 2 gm by c square.
This question?
Yes, ma'am.
See, for this you have to have a little bit idea about the black hole. Though this type of question, these types of questions were there when you are solving the questions of gravitation, you will find. See, black hole is basically what? Black hole is just a space in, it's a space or a hole, you can say, in universe where gravity is very strong. The gravitational force that is acting, gravity is very strong. So light, if you take, light means the speed of light. Light, if you take, you consider the electromagnetic waves. Electromagnetic waves means X-rays, gamma rays, microwaves, ultraviolet, all these come under electromagnetic waves. Electromagnetic waves you will study in class 12th also. So these electromagnetic waves plus light, because electromagnetic waves travel with the speed of light. So ultimately it's the speed of light that has to be there to this much enough energy is there to escape it. All right, this much energy is necessary to escape it. Now, when we are talking about this, coming to this question, so this you have understood, electromagnetic waves, if you're talking about light, we're talking about anything, this value of speed of light 3 into 10 to the power 8 is necessary. Now it says using the concept of escape velocity. Using the concept of escape velocity means using this formula, v is equal to under root 2 gr. Calculate radius of black hole. You have to find out this. Now see, velocity, this is the minimum velocity. Speed of light, I told you, this is the minimum velocity for any electromagnetic wave or any light ray to pass through the black hole. This has to be the minimum value of velocity, which is 3 into 10 to the power 8 meter per second. Now, if the velocity is minimum 3 into 10 to the power 8 or more than this, if you have a value more than 3 into 10 to the power 8, then it would be better to escape, because this is the minimum value. Below this, nothing will be able to cross the black hole. So to cross it, you have to have a minimum value of this, but more than this would be, then the body will be able to escape it. Here you will enter, but for the best result, not to actually escape it, because we are talking about escape velocity. So velocity has to be greater than speed of light. You can even equate it, equal to or greater than speed of light. All right, both you can take. So when we have taken v is equal to, see, r is on this side. So when r will come here, the radius will change. This you have understood, no? Why radius is less.
Ma'am, can you explain that too?
Just see. This is 3 into 10 to the power 8. When we're talking, velocity is greater. Right. So when we have taken velocity to be greater, velocity is greater than the speed of light. Now, what is the velocity which we have considered? This is under root 2 gm. So see, our velocity is greater than 3 into 10 to the power 8. So if we use this formula first, we'll have v square is equal to 2gr. So when we are seeing 2gr, this is c square is equal to 2gr, which we have considered. Now c square, the velocity which we have taken, this is actually greater. C square which we have actually assumed it to be c square. Velocity is equal to c for our calculation purpose. But this is the reality. Velocity should be greater than the speed of light. All right. So r will be less than c square by 2g from